Hi, dear students. After a short break, now let us continue. The subject is sheet metal work, okay, and the software is Inventor. I have already introduced you to the sheet metal facilities of Inventor, okay, starting from the template option and then configuration stage, and then just after having a rectangle as the sketch, applying the process. Yes, remember we had this part of the work, and then applying a flange process, creation process, had such a banded folded part. And also studying on this example up to this stage, I inform you that in Inventor, if the selected template is sheet metal template, can find this valuable button to click to be able to see at any stage or at the end the model of the object, okay. It is to have before the folding bending stages. Clicked on this and then see the unfolded form of the object. Yes, now here re-clicked on this button, go to folded part and then see the model in its available bended form. Okay, and then continue. Well, my purpose is to inform you on the functions of the other tools. Well, here I'm going to create an interrupted folded portion. Okay. Well, zoom in, and then by the way, here this flange, you see in this orientation can say that it is the folded part in the down direction. But if the part is to be say in the upward direction, then we'll see how. Bring the cursor onto this icon, it corresponds to this part, and say that edit it. Right click the mouse, okay, and then select edit feature. You know, it is always true. If you have a feature and need to edit it in shape or in size, then select edit feature option to be able to change the process parameter. Select edit sketch option, okay, if associated there is a sketch, of course, okay, to modify the sketch in shape or in size. But here, I'm going to change the parameter of the process, so select edit feature option. And it is the same dialog box, flange creation dialog box. Well, if the direction of the bended part is to be reversed, here is the flip-flop facility. Clicked on this and then have the bended part as extended in the up direction, down, up. Yes. And then say OK. And here one more time highlight that say here what we have a transition part, this round, and Inventor created this round just at the background, calculating the bending allowance. Okay, when we see the work in this form, clicking on go to flat pattern button, see the sheet metal work say as unfolded over there with the corresponding bending allowance. Okay, and then yes, over there assume that need to have a folded part, bended part, but it is not to extend from here to there. Okay, well, there is an unfolded part, and between them there is a folded portion. How it is created? How an intermittent folded part can be created? Answer this question. Zoom in, and then take a sketch right over the slender surface. Left click, right click, and new sketch. Yes, see, in sketch mode. And then, well, I'm going to apply the projection process for having a shoulder. Okay, let me have the projection of this edge. Okay, and then create a rectangle. First arbitrarily, and then dimensional constraint from the edge of that surface to the beginning of the bended portion. Say that the location dimension is 60. Okay, and the width of the bended portion, let's say, is 50. And relative to this reference, the height of this, size of this bended portion, say that it is demanded by the customer, or it has been decided by the designer, considering the function of that sheet metal work. It is 30. And then trimming process. Trim this part, trim this, trim that, to be able to precisely locate the terminal points of the sketch along this boundary of the surface, and finish that sketching stage. Yes, you see, I have such a rectangle over there. And then, yes, apply a phase process. Clicked on this, and then say OK. Just say OK. And then see the magic. Well, you know, if the folded part is just such a one, not extending from one side to the other side, but, well, such an interruption. After this interruption, then we have a bended part. Then, you know, to be able to prevent tearings, well, need to have reliefs. Okay, well, zoom in, and then see that the relief, necessary relief, well, has automatically been created here. And also, well, the bending allowance, this transition part, also has been perfectly created by the software. And at both terminal portions, you see we have such cuttings to be able to prevent possible tearings. These are needed. These are strongly recommended. And, well, this relief has been created in the standard common size. Okay. And then at that stage, for testing, clicked on Go to Flat Pattern button, and then see the development, unfolded form of the model of the object. These are the reliefs. Okay. Continue. Now, to be able to inform you on the function of this facility, fold facility, well, see my demo. Take a sketch right over the surface of this segment, right click, new sketch, and then, well, create a straight line. In this example, it is to be over there. To be able to trim the further extensions via which locating the terminal points of this sketch as precisely located along this boundary, along that boundary. You know the technique, trimming technique. First, have the shoulders at this stage. While applying project geometry process, have the projection of this edge. have the projection of the other, and then trim. Say that this portion is unnecessary, this portion unnecessary, and have the terminal points of the sketch precisely along the boundaries. Dimensional constraint: from this projected line to this terminal point, say that distance in this example is 40. Location dimension: from here to there, okay, say that it is 50. Finish the sketching stage, and then have a look at apply folding process, and then while at this stage bend line. Along which path the sheet gonna be folded? Here is the answer. Indicate this line, and then see the simulation. We have, you see, two green arrows. Well, one of them is bended in this direction. Okay, Inventor bringing this green arrows, saying that, yeah, well, while this part is being say folded using, for instance, a certain gripping tool, this part will be folded along this edge. Is it the case need to fold this portion in the up direction and folding angle 90 degrees or less than 90 or greater than 90? Well, this is the box to write the fold angle, and you know fold angle is measured from the outside. Actually here, good idea, bring the presentation, my presentation to the screen one more time. Sheet metal folder, and this is the presentation file. Yes, and then refocus your attention to this figure. Yes, angle A, bend angle, is measured at the outside of the bended portion. Okay, not as acute angle but obtuse angle, complementary angle. Okay, and bending allowance, calculating the size of bending allowance, you know, while we are seeing the sheet metal work as unfolded, okay, then the length of the portion it corresponds to the round or from this side fillet is called bend allowance. There should be such an additional material over there. Thanks to the existence of this additional part, allowance can have such a round. Okay, so okay, well, here fold angle is 90 degrees, let's say, and this part is to be folded in the up direction. If it is the case, say clicked on OK. Yes, that is right. You see, this part is folded in the up direction. Okay, then say oops or edit feature, and then change the direction. How you can change the direction for this bending? Well, see this one, flip direction. You see now, clicking on this, I said that it is the part of the object, it is to be folded in the opposite direction, and then say OK. You see this folded part is in the it has been bended in the down direction. Okay, one more time, bring the same dialog box, selecting this icon, it corresponds to this part, and after right clicking, selecting edit feature option. You see fold location, it is also important. Make zoom in and then see the effect of clicking on such buttons. Clicked on this, yes, it is the automatic select option, but if I clicked on that one, then you see bending allowance is measured, okay, at the part of the object it is going to be folded. You see these red colored lines. If the fault location is option is this one, then the bending allowance, half of the allowance is measured here, half of the other half is measured there. But if I clicked on this one, then bending allowance is marked, is measured, well, just at the region of the part it is to be bended. If it is selected, then bending allowance is measured not over the surface of this part, but over the surface of the rest. Yes, be aware, we can change the part over which bending allowance gonna be measured. And while the transition part, for having transition part, this means we're going to use the part of this portion. But if we select this one, then, well, the material at this part is used for having the round over there. But selecting the first option, then equally, well, half of the bending allowance is measured over the surface of this part and measured over the surface of the other part. Okay. Say that need to bend this one in the down direction. Bending angle is, fold angle is 90 degrees. Well, here, if it were an interrupted bending, then we would have at the beginning, at the end, the necessary reliefs. Clicking on this one, then can see that, well, the already selected configuration options are valid for creating such a folded portion as well. Unfold option, you see, Inventor knows that we use K-factor method. And then say OK. Yes. To be able to study on the function of cornering facility, corner seam facility, I'm going to create one more flange over here. Start the flange creation process and then indicate this edge. Which one, this or that. Thereafter, using the bend position facilities, can have the bending allowance either at the part of the flange or at the part of this part. I selected this one, and default configuration just created the ready to create the flange in the down direction. I'm going to flip the direction. And then, well, the fold angle, flange angle is 90 degrees, let's say. And then the length of this part have the same length, say 50. Okay. You see, while selecting this one, please pay attention to the changing. If I select this one, then the bending allowance will come from the existing part. But if I select this option, then the bending allowance will be a part of this flange. Yes. Or if I select this one, half of the bending allowance, for half of the bending allowance, this sheet, this part of the metal work is used, and the other half of the bending allowance comes from the flange, this newly created one. I'm going to say that, well, have the bending allowance while using the material of the flange. And then you see, well, at this transition part, meeting part, we have an empty space. Okay, then click on apply button, or just if you have no more thing to do, then just click on OK button. And then yes. Then after having such an edge with such a gap between them, actually in practice, well, why not, after having such a joining part, well, can apply welding process, for instance, to be able to connect this to the other. But here, before studying on the welding stage, well, see the effect of this facility, function of this facility, corner seam. I started the process, and then I'm going to connect this end to the other while using seaming technique. Okay, well, edges, indicate the edges. Indicate this edge, indicate that edge, and then see the changing. Yes, if I select this option, then you see there will be, please see the green prismatic part. Inventor saying that if well, this inner edges are indicated, and then this meeting option, gap option is selected, then well, this part of the sheet metal work will be little bit extended in this direction. This one, this flange will be extended. Inventor will add extra material, okay, changing their size, and then say apply, for instance. You see, well, this flange has extended few millimeters in this way, this flange as well in that direction. Okay, if I say that edit, bring the cursor onto this and then edit feature, and then say select not this option but that option, then you see, well, the first flange is kept in its existing size, but the other flange you see ready to extend, well, for seaming purpose. If I say OK, or just allow you to see the things in this direction, and then see the changing. If I select this option, you see there will be such a further extension here, further extension there. Well, the flanges will be extended. Well, such additional ending part will be added, will be created by the software. But if I select this option, then see, well, the size of this flange will be kept, but the other one will have such a furtherly extended portion. Select this one, it is opposite. Then while this flange is in its existing size, but the other flange will have such a further extension. Which one is the case in the application? This one, or that one? Okay, say that this one, or that one. I'd say that this one, and then say OK. Yes, you see, this flange is now in a greater size. If I apply the process, well, by the way, another thing, edit feature, right click, and then you see, well, we have percent overlap. Well, see the effect of this tool. Existing default value is 1. Change it to 2. But you see here it is in red color because Inventor saying that this number can be 0 or 1 or any other between them. Say that it is 1, it is okay, or say that it is 0. Well, see the changing. Well, the green line, green rectangle, just to say that at this stage, well, if we say OK, then there will be such a further extension. This flange will be furtherly extended. If it is 0, this parameter is 0, then it is going to be in this order. But if I say that 1, yes, well, the extended portion to its ending surface will reach to the plane of the other flange. Okay, be aware there is such a facility. Gap size option or measure. If we select gap size option here, okay, then yes, well, changing this parameter can have the size of the extension smaller or in this maximum order. Okay. Unfolded form. Yes. Continue. Now here, say that over there we need to have a cutting rectangular in shape. Okay, clicked on or this part, say that we need to have an empty space. Select this surface from this side or say this surface or the opposite surface, not so important. And then, well, create a sketch, rectangular in shape in this example, over this sketch plane. Since it is coinciding with the surface of the flange, then, well, it is going to be considered as if scribed over the surface of this sheet metal, and then the rest punching process, cutting process. Using a press, punch press, and a certain special die, well, cut the material. Well, I'm going to locate this empty space relative to this edge. So, well, first apply projection process, have the projection of this edge, have the projection of, yes, this projection is sufficient, okay, for inputting the dimensional constraints from, well, if you want, you can much more easily see, change the angle. Okay, the simulated light source is illuminating, lightening the surface, so you can much more easily see what I am doing. While relative to here, this boundary of the empty space, which is the necessary sketch for creating an empty space, is, let's say, equal to 40. Okay, and the distance from the terminal point of the screen line to this boundary is equal to 10, and the size of the empty space, let's say width, is 60. Okay, and it is height, well, such an empty space is needed, say that 50. Finish the sketching stage and then apply the process. If it were not a sheet metal work but any other object, then I would say that apply extrusion process in cutting mode. But here, use the tools of sheet metal ribbon. Well, to be able to create an empty space, yes, apply cutting process. Clicked on this. Inventor will automatically detect the existing sketch and then just say that OK. Yes, here it is, the empty space. We cut the sheet metal using this technique. After having the necessary sketch, say these are the boundaries of the empty space to consider in the mind, then apply cutting process. Okay, now how about punching? Well, make a demo to explain the function of this one. It is a drawing process, deep drawing. While you're holding the sheet metal, then you're applying a force, deformation force, and since you are using a special ram, okay, in a ram in special shape and size, then the created feature, which is going to be a combined feature, going to be in say special emboss. Okay, just plastically deforming the sheet metal. Okay, well, the technology we say deep drawing, we can create embosses. Well, see, first select the surface and mark the center of the emboss. New sketch, and then say that using point marking facility, okay, place a point. Well, it is the point to consider as the centroid of the surface for the surface of the emboss. Okay. Well, apply project geometry process, have the projection of this edge, have the projection of that edge, for instance, and say that in this example we know the location of the center of the surface of the emboss with respect to those edges. Dimensional constraint from this projected boundary to the point, distance say that is equal to 50, and from this projection this boundary and to the point, distance let's say is okay, then 40, and then finish the sketching stage. You see over the surface I have such a mark. It is to be marked as the centroid of the surface of the emboss, and then the rest. Apply punching process, clicked on punch, and then well, in this dialog box please see this preview window. Well, shall you create such an emboss in this shape? This one, for instance, say applying the punching process, have a part embossed in this shape. Cut the metal and then say that you may use that part as the say socket for say cable connection, serial cable in computer hardware, or parallel connection, serial connection port, parallel connection port, etc. These are standard geometries, or this one, that one, this one, this one. If the sheet metal work is to have a part of a door, it is made of steel, and say need to have a keyhole, yes, select this one and then well punch the apply the punching process to be able to create such an empty space in this shape. Okay, it is in the famous key geometry. Okay, keyway, keyhole, keyway, round, round emboss. Here I'm going to create round emboss, square emboss, round emboss. Say that need to have an emboss, it is a round emboss. Okay, and then clicked on, after selecting this option, clicked on open tab, and then be in this dialog box. Yes, here in this configuration dialog box, round emboss, idle, the other option, yes, the selected option can be seen in this punch pane. And then well, here geometry, yes, the say the drawing angle, deep drawing angle. Well, if it were a square emboss, then well, I will demonstrate the effect of changing the angle value. Well, next example, okay, following stage, you're going to see the function of this box. But here says size option. Although at the beginning it is strange, but it is a fact. At the beginning we selected metric unit system. For this facility, applying using this facility, the size values you see are shown in this pane in British unit system, inch. Diameter of the circular emboss 1 inch. Height is means depth of the emboss is 0.25 inches. Is it possible to change those numbers? Make a click and then yes, well, we have such size diameter option, minimum 0.75, maximum 1.5 inch. Is it possible to write a number, erase, and no, you see, cannot change the value, only need to use the listed ones, one of them. Say that diameter is 0.75 inches. How about the depth of the emboss? Well, existing value 0 to 5 inch. Make a click and then click on this listing arrow. Select the minimum value 0.25 inches. Okay. And then the rest, say finish. You see, if you mark the center of the flat surface of the emboss at this side, then embossing will be in that direction. Okay, and see the other side. At the other side, you see we have a blind cavity. One side it is embossed, but you see at this side we have such an empty space. Deep drawing process. Okay. And then to say that, well, the cavity will be at the opposite side of the surface on which we mark the centroid of the emboss. Well, in this case, mark the center of the emboss at this side. Then, well, at this side, I'm going to have the emboss, but the other side, empty space, blind empty space. Take a sketch right over the surface and then say new sketch. And then, well, select point marking process, of course. Mark the point. It is in the mind to consider the center of the flat surface of the emboss. Okay, dimensional constraints. Project geometry process relative to this edge, relative to that edge. Well, say that I know the coordinates. Dimensional constraint, from this projected boundary to the point, distance is equal to 80. From this projected boundary to the center of the surface of the emboss, it is equal to, let's say, 35. And then finish the sketching stage. And then apply punching process. Well, select square emboss option and then say OK, open. Click on open button. Now see the simulation. Well, the boundaries of the square emboss is in this simulation. Say to its boundaries, it is in this simulation. Well, the dimensions, the unit of measurement the same in inch, unfortunately, although we selected the template option at the beginning, selecting metric option. But here in this tool, while the default configuration directly selects inch as the unit of measurement. But we can change the size. Click on this one. And then first study on the effect of this number, angle. Well, since it is not a round feature, but rectangular or square feature, then, well, say that if the emboss is to be oriented, created as oriented like this, it's okay, angle is 0. But say, change the angle, please see the simulation, changing on the simulation. For instance, 30 degrees. You see now the emboss will be tilted 30 degrees. Okay? 5 degrees. Or 45 degrees. Okay, it is possible. That is the function of the angle box. Okay. What else? Size value. The available numbers, for the available numbers, these are, you see 1 by 1 inch is the size of the emboss. Depth of the taper angle is 30 degrees. It can be changed. While the depth of the blind cavity is 0.25 inches. Okay, well, is it possible to change the numbers? Click and then drop the list. Here it is possible to select those numbers from the list for which the unit of measurement is millimeter, or just directly write it. Well, the length of this emboss, say that, well, one dimension is say that 20 millimeters, write millimeters, not inch. And then select this one. You see here now it is shown in inch. 20 millimeters equals to 0.787 inches. Okay, and the length is 1 inch. No, not 1 inch. Say that it is 10 millimeters, and the height, depth of the cavity, say that 2 millimeters, or say 3 millimeters, Taper angle 30 degrees. It can be changed, not 30, but say that 20 degrees, for instance. Okay, well, creating the emboss, we have inclined side surfaces. For the inclined side surfaces, this is the angle, inclination angle. Say that it is 30 degrees. And then try whether the numbers are okay. Click on finish button. Yes, that is good. You see. Now the emboss is at this side. At the opposite side, we have a blind cavity. And the inclination angle for this inclined side surfaces is 30. Well, change the parameter and then see the changing. Right click the mouse when the cursor is on punch icon, and then say edit feature. Here I'm going to change the angle from 30 to say that 20 degrees, and then say finish. You see, well, the inclination is smaller, not 30 relative to horizontal reference, but relative to the surface of this sheet metal, not 30 but 20 degrees. Okay, so on and so forth. I think this part is okay. And then one more thing, at this stage clicked on go to flat pattern button, and then see the unfolded form of the sheet metal work. Okay, at the beginning, over a flat sheet, the necessary figure to draw just comes from the boundaries of this flattened model. After having the boundary lines as scribed over the sheet metal, then along the edges fold. Well, along which edges the sheet metal unfolded stock is to be folded, in which direction? Well, here Inventor highlighting the say the mid part of the bending allowances, bringing green lines. Okay, green, long dash, short dash. These are the paths along which, well, the sheet metal is to be folded. Okay, if you clicked on this bend order annotation button, then see a valuable thing. Inventor saying that, well, to be able to have the sheet metal work in its final form, in its desired form, first mark this path, and then along this path fold this portion first, and then after bending this part, then, well, bend this part of the stock, and then, well, bend this part, and then bend the other. Okay, Inventor just offering such a way, step by step, bend the sheet metal along those paths in this order: first, second, third, fourth. Okay, go to folded form. Yes, say that, assume we finished the model creation part. It is a sheet metal work. update the file say, and then how about the views? For this object, let us have the necessary views. It is going to be a new file. Clicked on new file creation button. I selected metric quadrant. Metric option means first quadrant. And drawing template iso.idw. Clicked on create button. A3 size paper. If it is sufficient in size, then okay. If not, then change the size of paper. Okay, I'm going to increase the size of paper by 2. Edit sheet. Right click edit sheet. Not A3 but A2 size paper. And then say okay. Start the view creation process. Of course, it's a good practice to enable the reader to see the front side, top side, left side, the necessary side views. Say that this is the selected side to have the front view. Okay, scale factor 1 to 2, try 1 to 1. This is the front view. And then move the cursor here, have the top side view. Move the cursor here, have the left side view. First style button is okay, correct option. Well, here you see this radio button. If it is a sheet metal work, sheet metal view pane have 2 radio buttons. Shall you create the orthographic view of the sheet metal work or create the development, okay, of the sheet metal work? These views, principal views, are to inform the reader on the appearance of the object. These are not so valuable. The valuable drawing is the one it shows the sheet metal work as unfolded. It is the figure actually to draw over the surface of a flat sheet. And then if there is a cutting, cut it along the edges, and then well, the rest is folding the sheet metal, then set it its final form. Okay, well, here my purpose is to create the views of the sheet metal work, not the development. So this radio button is correct, and then say okay. Yes, front view, top view, and then of course show the dimensions, necessary dimensions. If there is an axis to show, then show. Clicked on this. Since it is on the projection a circle, well, you know, need to mark the center point. Okay. To say that this is a revolve feature, which one is revolved? This one is a revolve feature. Okay, try to show it as longitudinal axis. Clicked on this and then show this surface limit, show this limit, and then have such a longitudinal axis. But since the other one is a rectangular emboss, you see, initially I selected square emboss, but changing the width height values, well, I had a rectangular emboss. For a rectangular emboss, for a rectangular extension, square extension, axis is not defined. So don't show the axis to highlight that this emboss is not cylindrical shape, circular in shape, but in such a form. Okay, for this one on the left side view, show the longitudinal axis by indicating this limiting surfaces. Okay, and then, well, of course, show the dimensions, width of the object, depth of the object, height of the object, and the location dimension for this one can be shown on this view. But show such things on the development. Actually, the location dimensions for the features show the measure of the location dimensions, and of course the size dimensions on the development. Well, start view creation process, place views, clicking on base view creation button. Only for sheet metal works at the say development creation stage, we clicked one more time onto the base view creation button. If the view is going to be not developments, but say principal views, then it is a must, clicked on base view creation button at the beginning only one time. Well, for creating the other views, if you started from the front side view, projection button is clicked on by the software at the background. If you had an interruption at the view creation stage, then to be able to create one more view, for instance, well, creating these views, after that I stop. So I had an interruption. But thereafter I decided to create not only those but one more view. Then I need to click on projection process. Clicked on this one, indicate the front view as the reference, and then for the right side view, then go in this direction and then create the right side view as if it is necessary. Okay, such things. Well, the advantage of starting from the front side view, etc. Show the dimensions. I'm going to skip this dimensioning part. At home you may continue on the rest and show the dimensions. Fill in the title block, writing the name of company, etc. How about the development? Click on base view creation button one more time, but in this dialog box select flat pattern option. To be able to have this option, don't forget it is a trick. In model creation environment, well, at least one time, here in this environment, at this one time clicked on go to flat pattern button. After having the flattened form of the sheet metal work in this 3D modeling environment, then yes, can have at the view creation stage, after clicking on one more time base view creation button, this radio button as available. Click, and this is to say that I'm going to create the development. Well, change the orientation for this development, and then one-to-one check whether it is possible to fit. I think I can fit the views. Say OK. Well, these three views are principal orthographic views, but this one is not front view, not top view, not left side view. It is called development. It is the projection. Okay, in shape, in size, it is to be marked over the surface of sheet metal, okay, via using special marking tools, scribing pens. And then after having this figure, then using scissors, special scissors, cut the sheet metal, have such boundaries, and then using punch process, well, create this relief, create this relief. After creating the reliefs, and also why not at this stage or thereafter, after the folding stage, using again dies and special rams, applying the necessary deformation forces, have this emboss, and then fold the sheet metal along this highlighted boundaries. Of course, this boundary is to be coordinated. Dimensions, well, quickly pass through the dimension configuration stage. Styles editor, you know this. And then select dimension option, expand the list, and then default ISO option. Precision showing the nominal values is to be in this order 0. Well, one of the video records in the content of this week, these are all to make a review on dimensions, dimensioning format. You can understand why I selected 0 precision at that stage. Clicked on save button, and then display option. At the beginning of extension lines, 2-3 mm empty space is needed. Okay. Well, for the successive dimensioning rows, the minimum distance is to be 8 mm. Well, the first coming dimensioning row with respect to the utmost boundary is 10. These are correct. Size of the arrow 3 mm. Clicked on save button. Okay, and then text option. Clicked on this editing button, and then select Arial as the font name. Okay, font size say 5 millimeters. Clicked on save button and clicked on back. And lastly, while selecting nodes and leaders option, and from here for the annotations to have their landing parts, horizontal tails, select horizontal tail option. Clicked on save and close this dialog box. Okay. And then show the dimensions. Axis. Location dimension. Well, for instance, for this relief, show the location dimension. Yes, relative to here. Well, technician is to measure 49 millimeters. Okay. To inform the other technician for the starting point for this relief. And also, well, this dimension is to be shown. Okay, well, it is to say that mark the path along which this part is to be bended relative to here, measuring 49 millimeters. Okay, and show this coordinate values. Okay, to locate the terminal points of this path along which this corner of the object sheet metal will be bended. Okay, and the location dimension for this cutting relative to here, for instance, show this dimension. And then the size of this cutting, height of this cutting, well, can show it over here or just in the vicinity, maybe more suitable, so on and so forth. Well, for this relief, location dimension relative to here. Okay, show this dimension. Okay, to use to locate this relief. And say there are some other dimensions. Assume that I show all the dimensions. Well, from here to there, for instance. What else? Clicked on punch button, start a process, and then indicate this punch. Then yes, Inventor UC ready to create such an annotation. Inventor says that here, if you're observing the sheet metal in this direction, then apply the punching process in the down direction. Okay, 180 degrees. How about this punch? Indicate this punch and saying that in the not down but toward the eyes of the observer in the up direction. Okay, apply the punching process. Okay, for the inclined surfaces, the inclination angles. Here 180, there 135 degrees. How about the bending ready and bending angle? Well, clicked on, for that purpose, bend button, and then indicate this lines, path lines. Then, well, Inventor will add this technical note saying that to be able to have the object in its final form, this corner is to be bended 90 degrees, rounding radius is 1 millimeter in the down direction. Show this one, saying that, Inventor saying that, well, operator along this path is to bend this portion in the up direction toward the eyes of the observer. Indicate this one and have this annotation. Indicate this one, have the annotation. Well, the sheet metal is to be folded in the up direction, not down but up direction. 90 degrees. Yes, these are valuable annotations, valuable notes. On the development, show such dimensions and have such technical notes. press escape button. And then, well, if you have such a clash, then yes, why not hold this technical note and then bring it here along the edge. But say some cases writing the technical note along the folding path may not be convenient. Then say, for instance, if you hold this one, then you can have such a leader line instead of having the text as written in alignment with the path line. If you move the cursor via holding this text away, then you're going to have an annotation. Hold this one and then yes, drag it. Yes, you see, it may be more suitable to show this technical note using an leader line, so on and so forth. Okay, I think the things to do for creating the developments and also the dimensioning part are both clear enough. So, well, why not save the file first and then, yes, if it is the address correct, yes, then click on save button. Write the file name, surname of the user, okay, ID number, staff number, and then say that this is the first class work, CW1, date is the 3rd of November, NOV3. I found such a file. Yes to all, okay. Okay, now reach to the end of this class work. Allow yourself to see my face. Okay. After having a break, I'm going to give another example, my dear students, in sheet metal creation environment, sheet metal work environment. Okay, see you then. Stop recording.